एवरीवन, आज है अपना डे 4 ऑफ डूइंग डिफरेंट पैटर्न्स ऑफ डीएसए। सो आज हम करेंगे प्रीफिक्स सम। सो मान लो मैंने आपको एक अरे दे रखा है, जैसे गिवन है, और मैं आपको क्वेरीज पूछना चाह रहा हूँ। मैं पूछ रहा हूँ कि लाइक यू हैव टू फाइंड सम फ्रॉम इंडेक्स ए टू बी। मान लो अगर मैं पूछ रहा हूँ कि इंडेक्स व्हाट इज द सम फ्रॉम इंडेक्स 1 to 5। सो what will you guys do? You will use a loop from index 1 to 5, and then uh, you do the sum. So same way, if I ask you again 1 to 10, again you will use the same thing, loop from 1 to 10. So what, but every time, if you'll see the complexity, every time you are using a loop from b to a, so the time you are taking is of b minus a. But what if I ask you that you have to do it in constant time? So how will you do that? So for that we use prefix sum. So what is like prefix sum? So basically what we do is we store the sum of all the elements uh, at an index I. So let me show you with an example. Suppose the same array we have. So at index 3, we have stored the sum of the elements at index 0, 1 and 2. So at any point I, we will store all the sum of all the elements before that index I. Prefix of I, what it will tell us? It will show us the sum of elements of array from 0 to index I. How we will calculate the prefix array? So prefix of I is equal to prefix of I minus 1, means sum of elements till I minus 1 plus the element at the ith index. So in this way we'll get a prefix array. And now suppose we have to give the answer of any range query, so finding sum from range L to R. So what we will do is prefix of R means sum from 0 to R minus sum from 0 to L minus 1. So this will give us the sum from range L to R. And see, this is we are getting in constant time. Let's take another example. So this is an array, and this we have calculated the prefix array, like 2 4 6 4 6 1 7 7 3 10 10 6 16. So this way we get our prefix array, and then we are given a query to find the sum from 1 to 3. So prefix of 3 stores all the sum of all the elements up to 3, and prefix of 0 stores the sum of element up to index 0. So if we take the difference, we will get sum of all the elements from index 1 to 3. So we are and when to use prefix sum? Suppose we have to find multiple range sum queries, like as I explained you above. Yeah. Second, when our array is static, that is we are not updating the elements, or we need of one queries. But there is one case, suppose uh, we want range queries, but our array gets updated after each iteration. Then we won't be using this prefix sum. In that case, we will be using Fenwick tree or segment tree. Same way, prefix sum is also applied on 2D arrays. So So in 2D arrays also we have to calculate the sum, but right now, like earlier, we will be checking in only one direction, but in 2D arrays we will be checking in two direction. So there is a one formula for calculating prefix of I and j. What prefix of I and j denotes? The sum of the all the elements in the rectangle starting from 0 comma 0 to I comma j. So how we will find that? So for that, I'll show you using this matrix. Suppose we want to calculate the sum of this rectangle, so what we have already, calculated, right? The We have already calculated the sum of this rectangle, and we have the sum of this rectangle, right? We have already calculated these two rectangles. So what we do is we will add this and this rectangle, and then subtract the common part that is coming in both these two rectangles, we will subtract this from the sum of these two rectangles and then add this element. So in this way we will get we are using this formula. See, matrix of I comma j, matrix of I comma j yani 2, prefix of I minus 1 j yani this one rectangle, the above rectangle, prefix of I j minus 1, this rectangle, this one, minus prefix of I minus 1 j minus 1, subtracting the common part that we have taken. So I hope you get the like when to use, how to use and everything. So if you understand this thing, you should try these four problems, and thank you, that's it.